Good morning, everybody, and welcome to the next installment of our Red Hat FAA webinar series. So I'm excited. Spring has sprung, baseball is back, and the Phillies are in first place today. I'm sure that won't last long, but hey, at least we can say it now. Um, Many of you know, my name is Jonathan Beach, and I'm your FAA dedicated solution architect. Today we have a pretty cool webinar. Um, as many of you know, the FAA has many facilities, many sensors. Some of these sensors are big, some of them are small, some of the facilities are big and small. And they're spread out throughout the entire country and even OCONUS sites. Um, so with all of that, it's kind of difficult to run your infrastructure. Just some of these use cases, could utilize Red Hat Enterprise Linux for the edge. So today, our presenter is going to talk about using that edge for many of your use cases. But as always, before we get started, some ground rules. First, by default, we cannot hear you or see you. We mute everyone's microphone and turn off everybody's camera. So with that, we ask that you put all of your questions into the Q&A section of your web browser. You'll see a Q &A. So please drop all questions in there. There is also a chat function. Please send us some good things, some bad things, anything along those lines, and let us know if you can't see the slides or you need us to speak up or anything like that. But yes, it's very important to drop those questions in that Q&A section. As our presenter is going on, Jeff Thompson and I will be answering any questions that pop up. Our presenter will be taking pauses throughout his presentation as well. So we'll ask the questions to him and we'll get them answered. And at the end of the presentation, if some of those questions aren't answered, we'll do our best to answer them, or we'll follow up with you afterwards. And also during the presentation, I'm going to drop some information into the chat function. I'm going to drop my email address. If you have any questions after this presentation related to anything in the presentation or anything Red Hat related, always feel free to reach out to me. I'm also going to drop in there a link to our Red Hat Summit. I'll explain a little bit more about that later. I just want to drop that link in there sooner than later. So we're tired of hearing me talk today, so let's get started. Today we welcome back a familiar face of the FAA, Sebastian Dunn, a principal solution architect here at Red Hat. And with that, Sebastian, let's talk about edge computing.
Okay, thank you for that introduction. Are you seeing my title slide?
Not yet. I see you.
You're seeing me, but not the title slide. Okay, hold on. Let me just.
There you go. Look good.
Okay, good. And that's just the title slide?
Yep. Yeah, just real quick. If somebody can't see the slides, please drop it in the chat and let us know that we had one case where presenters could see them, but the audience could not. So just let us know if you can't see the slides and we'll go ahead.
Okay, great. So again, thank you for that introduction. Again, my name is Sebastian Dunn. I'm a principal solution architect here at Red Hat. I mean, going into my 6th year here at Red Hat, and for almost all that tenure, or most of that tenure, I worked with the FAA. The FAA was one of my first customers at Red Hat. And I still work very closely with your core account team of Nick Salvatore, John Beach, who did these kind introductions, and Jeff Thompson as well. So thank you for your time today and the account team to letting me come and present to you today. And again, I do not mind pausing at times. John and Jeff, if you see something you think I should stop and answer, please let me know, and I'm happy to do that. But we're going to talk about first about edge computing. Why edge computing, but maybe more importantly, what is edge computing? And then why are we talking about it now? What's changed in terms of the industry or in terms of your requirements or in terms of the technologies that have evolved to make this a compelling topic right now? And then why Red Hat, right? So why leverage your enterprise agreement with Red Hat and look at those technologies specifically, and why perhaps even open source technologies as opposed to a proprietary solution to some of the challenges that we're going to talk about. And then we're going to dive into, those actual recommended Red Hat solutions. So what are the technologies that address those challenges that we're going to be talking about? And then we'll conclude with some more Q&A, answer any other questions you've got. And of course, we can continue this conversation. We're happy to follow up with you on a later day with more details, or maybe even another webinar where we do a deep dive into some of these technologies. What's driving this solution, or what's driving this thing that we call edge computing? Well, part of it is, you've probably heard of the Internet of Things, or IoT, but I want to make it a little broader than that. I don't want you thinking just connected thermostats and smart refrigerators. We're really talking about anything that exists on the edge of your zone of connectivity. And that can be autonomous vehicles, that can be planes, that can be drones. I don't think you can have an edition of the ATCA journal, the Air Traffic Control Association journal, that doesn't mention something about FAA's effort in helping control how drones can be used efficiently within the national airspace. So that's definitely a major driver. Then there's always been a driver to reduce, the hardware footprints that we have to put into the field. Every time we put something out there, it needs to be maintained, it needs to be managed. It's an expense. The more expensive it is, the fewer of them perhaps you can deploy. But when you deploy just one of anything, it becomes a single point of failure. So this has been a constant driver in the IT industry, is how do we deploy compute closer to the edge, but do it in a cost-effective, manageable way. And then thinking back to those vehicles and drones and even other devices again, what we're looking for more now is sort of actionable intelligence at the endpoint. It's not enough just to detect something and then report it to a central hub and then do something about it. We may want those things to happen faster, right? We want and need those faster responses to what's out there in the field. So again, it's maybe less important with a smart refrigerator. Maybe it doesn't matter that if you're out of milk, it doesn't alert your mobile device for 5 minutes. But maybe you don't want a drone that's drifted into restricted airspace to be there for more than 5 minutes. So in the first case, maybe this hub and spoke method works. In the second case, maybe it doesn't. And then, as we sort of mentioned at the beginning, the moment we deploy those systems to the field, they start to become stale. Stale in terms of features, stale in terms of the security fixes that maybe need to be applied to them. And what we really want to do is create a different way of deploying things so we can add features, we can make changes faster. Good example of one of those may be like the telecom industry and the way they rolled out 5G. So the way, and I think I've got another slide that talks a little bit about this as well, but the way they've rolled out these new systems, and I would call them, they are edge systems on towers to provide you that 5G service. They've deployed it in a way that the functionality is not hard-coded like it might have been before. So there's the concept of something called VRANs, V-R-A-N, but it's the idea of a virtual radio access network as opposed to inflexible, non-changeable hardware that did only one function. So they're trying to build smarts because they know that in 5 years, they don't want to have to replace all that. They want to just be able to build in new functionality into that same platform. And data is also a challenge. There is a huge amount of data that is going to be coming from all of these devices in the field, from the simplest to the most complex. I just read an estimation that a single autonomous vehicle will produce 4 terabytes of data per day. So, and that's just one self-driving car or one self-driving vehicle, for example. So then the challenge becomes, what do you do with all that data? How do you make it actionable? Do you need to save it? How do you store it? In a single vehicle or something like that? Or how do you even transmit that data to somewhere where you can do something with it? And that brings us to our last point of that then becomes a bandwidth challenge, right? So 5G may solve that bandwidth challenge for many customers, but I know the FAA very well, so does John and the rest of the account team, and we know that you are constrained by the cost and the bandwidth available within FTI today. Lots of FAA locations, important FAA locations, have very constrained bandwidth, far less than your mobile phone in many cases, and it's expensive. So we have to think of clever ways of being able to deploy what we need to deploy with things that are, can use low bandwidth, or things maybe that are even just intermittently connected to a network. And some of the challenges are common, right? We've sort of talked about, in this new era, we're no longer talking about hundreds of devices or thousands of devices, but quite literally tens of thousands or hundreds of thousands of devices. I believe DARPA has this interesting program they're doing in the Gulf of Mexico, where they're dropping literally hundreds of thousands of these sensors into the ocean to track ship movement. And they need a way to manage those. And there you obviously see the trade-off between the cost of those things and how many you can afford to deploy. So the question is, do you build a lot of smarts into that far endpoint, or do you make them dumb and cheap in order to deploy more of them? And that's really going to depend on the workload that you're trying to deploy to, or the information you're trying to gather. And then we get back to the data communication requirements. We talked about connectivity, we talked about bandwidth. There's also the latency, right? We have to decide, how much time can we really take to ingest data and then respond in some fashion. We mentioned the data storage requirements as well. So there's a physical scale, but we also have compliance requirements. We need to secure that data, right? So what's the best place to secure it? Do we want to secure it in something that could possibly be picked up and taken away, or do we want to secure the important data somewhere else? And then where do we convert that data to information and something actionable? Do we do it on that endpoint, which requires a lot of compute power, or do we bring it somewhat more into your controlled network to do that calculation of what needs to be done next? And finally, and this may be one of the biggest things, and certainly one of the biggest things we've seen with remotely deployed systems today, and honestly within FAA today as well, is that once things are deployed, it can be difficult to manage them. We know of systems deployed in very remote regions of Alaska. It may take days, it may take a helicopter or a boat to get to these locations, and that means that it's hard to keep them updated. And when you're deploying thousands of things as opposed to hundreds of things, consistency becomes even more important. So we need a way of ensuring that everything that we deploy is configured the same way and is working the same way. And then we also talked about security. We've heard about baby monitors being compromised and things like that. So, being able to respond to security threats is important. We can't lock down these remote systems to the point that they can't be changed even by us. So we need to find a way to make sure that they're hardened, but not inflexible, if you will. So how do we solve this challenge? And I would argue that in many ways, over a lot of time, we have solved this kind of thing in a similar way many, many times, which is basically to create a middle tier. So typically in networks like this, we start with a total hub and spoke methodology. For reasons of scale and cost effectiveness, we build a central data center, and then we roll out, individual devices that talk back to the data center. So the hub is cost effective, but sometimes the sensors aren't, because we need to build a lot of intelligence or add a lot of hardware out there so that they're resilient. And then how do you scale beyond maybe this many devices to hundreds of thousands or tens of thousands and so on? And then there's a little bit of a problem with all of that smarts in the hub, right? If you have a failure, in this diagram, I would immediately look at the hub and say, wait a second, I've got a single point of failure here. So anytime we deploy like this, that's also a challenge. But again, I would argue that we have solved this challenge many, many times by putting basically putting in an edge tier, putting in an aggregation tier or distribution tier, whatever you want to call it. So the idea is that with this kind of methodology, we can deploy and manage many more endpoints because they're less sophisticated than they were before. And we can do it with added security because now those endpoints perhaps can be a little more dumb, if you will, or cheap, and dumb and cheap. And the idea is that you can build more of the security into that distribution and aggregation tier, and you can harden those dumb and cheap sensors at the end in a different way and reduce their vulnerability footprint. You also get a little more resilience here, right? With more devices in the edge, and you can add more devices, you can have edge systems that go down, but you're still getting the majority of your data. The rest of your edge systems survive. And the same with these aggregation layers. Here you could lose one of those middle nodes, but you don't necessarily lose visibility into your entire system. So you do increase resilience with this kind of model if you build it correctly. And then this is probably less important for the FAA, but it may be important and I'm not aware of it, but this can also help meet what we call data sovereignty requirements. So there are definitely countries, there may be national or other regulations that say, the data for these systems or this kind of data can't, traverse state or national boundaries. And you can use a system like this to ensure that that stays the case and that you stay in compliance with national or international data sovereignty requirements. So to sum up, when we talk about edge, it's maybe even simpler than I've been trying to say before. And it's all about simply bringing compute closer to the producers and the consumers of the data. Right? And those producers and consumers can be many different things, many different endpoints, but this is really the way to think about it. Where do you put the compute that makes the most sense for the system that you're trying to create? And one of the first decision that organizations are going to have to address is how you want to adopt edge computing. There are already, some very large industry vendors that are trying to create an all-in-one offering. They'll provide you the hardware for your endpoint and everything in between, including the cloud capability and the software and everything. It won't surprise you that, I'm biased in the other direction, having been a customer of Red Hat for many years and now working for Red Hat today. I believe that the future is in open source based systems. I don't think there's any company that can do all of this soup to nuts. And Red Hat certainly doesn't try. We don't build hardware. We don't really build enterprise databases or some other key component. But all of these open source options are our partners. And a lot of them, the hardware vendors are all Red Hat partners. We work hand in glove to ensure that our software runs on their hardware safely and securely and with the performance that you need. So again, we don't pretend to be the best at everything, but what I'm going to talk to you about today are the technologies where I think we are the best in terms of meeting the challenges and creating a solution here. So really, we're going to talk about three components of this solution. The first is what we're calling RHEL for Edge. And that's basically a different way of managing the file system on the RHEL that you're familiar with today. It's just creating a different image and being able to manage that in a different way. And we'll talk about why that's significant. And then there's another option, depending on workloads, which revolves around using OpenShift, which is our containers and Kubernetes platform, to increase capabilities at the edge and in that distribution layer that we've been talking about. And finally, there's a glue for all of this. is if, as you can imagine, we talked about the challenge of maintaining consistency across thousands or tens of thousands of devices. You can imagine there's only one way to do this, which is with automating that process. This is something I think I've presented on hybrid cloud to the FAA. Oh, I've definitely presented to the hybrid cloud to the FAA many times, maybe even in this webinar series. But I said something there that, if you're not using automation in the cloud, you're not doing cloud correctly. And I believe that, and I believe that's absolutely true of these edge computing solutions as well. If you're not automating from the beginning, you're going to be creating a huge amount of technical debt for yourself moving forward, and it's just not going to be manageable or as successful as you want it to be. So again, think of the automation portion as really the glue. It's part of these other two solutions. In other words, you can deploy these other two solutions using Ansible, but the other two solutions you're going to see are different from each other, and we'll describe how. So John and Jeff, before we get into the actual meat of the solutions, do we have any compelling questions?
Nope, nothing yet.
Mm-hmm. Okay, great. So we've got the first column, the first row there is really what we call the RHEL for Edge solution. And then below that are the three rows of different ways of deploying OpenShift, the containers and Kubernetes solution. You can see Ansible is on the right-hand side there, really can manage all of this. And this doesn't have to be one or the other. They're not exclusive of each other. You may have parts of your system that can be rolled out on RHEL for Edge, and others where you want more of the containers and Kubernetes platform. And something else to point out is, there may be different fits in different ways. So for example, one thing I thought of in particular with the FAA with regard to these two solutions is the FAA has lots of systems that require a dedicated interface to, let's say, radar systems or other analog data systems that are going to be around for a while longer. So in those cases, it's probably unlikely that we can containerize those applications. And so those might be a better fit for RHEL for Edge as opposed to running on an OpenShift-based platform. Just as an example I thought of as I was putting these slides together. But again, we'd want to dig into the actual workloads to find out what is the best fit. So let's start with talking about RHEL for Edge, and then we'll talk about the container and Kubernetes-based options. So this is just a quick screenshot of what we call Image Builder. It's built into the web interface that you have on all your RHEL systems today. But what we've done now is added a new option called the Edge Profile. It allows you to create a new type of image based on something called OS tree. So I'm going to summarize what OS tree does, and then we'll dig into how it changes how you use this operating system. So OS tree really and so the community name of this project is libOSTree, but we can say OS tree for short. But OS tree really allows us to treat our file system, our operating system file system, as a collection of files as opposed to something that we actively manage. So, for example, you can take, when you create this image of, let's say, RHEL 8.3, you can end up with, and I show you what it looks like on my system here down below, but, a relatively small, here it's 638 meg, the entire operating system file system in a tar file. And maybe it makes sense now to back up and say, so without this, how would we manage these systems? Well, the way we manage these systems today is with a package manager. So you're familiar with RPM packages with RHEL. I know we tend to have a technical and non-technical audience on these, but bear with me for a minute. For the technical side of the audience, the way we typically install packages, new packages, or update packages is to use a package manager. And in RHEL today, that's called yum. So to install a new package, we might do a yum install and then the package name. And what's critical to know here is that that package is being installed and changed right then on the running system. Now, this may sound a little risky. Generally, nothing bad happens. You get the package you wanted. Everything works fine. It's checked for any dependency requirements and installed those as well. And generally, everything works great. But if something does go wrong, you're typically in a data center with skilled staff that can address the issue, remediate it, rebuild the system. There are many ways to get yourself out of a jam if something has gone sideways. But imagine doing this on systems that are in the field. And that's why typically on most of the FAA systems that are deployed into the field, you don't do anything like this. It's always been anathema really to make live changes on systems you have in the field, and you've come up with different ways of doing that with disk images or wiping the system clean and rebuilding it from scratch. Those are both methods that a lot of FAA systems use today. But instead, we're offering here sort of a middle ground. If the file system is immutable and exists as sort of a file, what we can do now is when you do that RPM install package instead of RPM OS tree install instead of yum install, what it does is it simply layers that new part of the file system onto what's already there in terms of a file, but doesn't change anything on the active running operating system. And only when you decide to reboot that system will it switch over to version B that contains that new package, for example, or that new change, right? So let's go to the next slide and talk about how that changes the way you do things with systems in the field. So again, you create those images of the file system, if you will, or those file-based images of the system. You can think, if any of you developers or know how developers operate, really what we're doing here is trying to be able to manage different versions of the operating system, much like we do software in a Git repository. So now we can have different versions of the software that allows us to do on the same system that allows us to do some really interesting things. So again, these OS tree commits, these commits of the file system, can be served up by a web server or a secure web server. The clients download this, those remote systems can download it and keep it handy, keep it staged until you're ready to do something. It can be an automatic update policy. Maybe they check in every 12 hours to see if there's a new update. That's all configurable. You can force them to check for an update, anything you want to do. But the important point is they don't do anything until you also then trigger a reboot. Your system has not changed in any way until you trigger that reboot. Now, what makes this even more efficient and compelling for these remote sites is that, remember when we talked about what it looks like when you add packages or add updates to that base OS tree image that you've got or that file? It's basically just a delta. You're just adding a little bit of information on what's changed since the first version. So what that means is that when you need to do an update to any of those systems, you're not having to update the entire disk image. You don't have to provide all the install instructions for every single piece on that system. It's already got what you initially deployed. So all you then have to add are the deltas, which is in a much smaller amount of data that needs to be transferred over a network or via a thumb drive, however you want to do it. So remember, only the updated bits of the OS content need to be transferred to that system. So, and we are certainly aware of many programs that, for example, in order to do updates, not only do they require a DVD, they require a DVD and maybe 50 pages of instructions. And all that work also means that updates don't happen often. Maybe they happen every 6 months, maybe every 2 to 5 years. But we believe, and I believe strongly, that with this kind of update method, it's much easier and safer to make deployments like this. Again, because you're not rebuilding the entire system. It's interesting to note too that we have, the small size of these initial file systems, and then any updates. We have some programs, for example, that are literally running out of space on a DVD for all the installation material they need to deploy RHEL, to deploy their third-party software, everything they need, build the system. A DVD just isn't big enough. That 5 to 8 terabytes of data is just not, or gigabytes of data is simply not big enough. 5 to 8 gigabytes of data. So what have we created here? So really, we've created an immutable operating system. When one of your versions of that file system deployed, in this case, it's either version A1 or A2, once it's deployed after doing a reboot, and it's only one or the other that's running at any one time, you can imagine there's lots of new things we can do. One of them is easy rollbacks. For example, I have a slide next that'll show you how easy that is. So if version A2 doesn't work quite right, you can immediately revert back to version A1, as simple as a reboot. And then we're getting closer here to an immutable, what we call an immutable operating system, where the binaries, the important parts of that operating system, all in the user subdirectory, are read-only. So imagine here for a minute something like a SolarWinds attack. Even if SolarWinds, agent was installed in the system, there's only certain things that it has access to and can change. Everything else is read-only, and you've reduced all of that vectors for attack on that system. Now, var and etc are both read-writable, and that's important for you to build working systems. But again, the important part is that we're closer here to creating an immutable operating system. Here's an example of those rollbacks. So not only can you just manually do a rollback with an RPM OSTree command, which is very easy, and then reboot, you can also build in intelligent rollbacks. So there's a service called Green Boot you can turn on that you can do a reboot, switch to version A2, and then run health checks. If there's anything that doesn't work, you can cause an automatic reversion to the last previous known version of that system. Now, hopefully, all of this is sounding pretty familiar to some other technologies that we believe we've talked about before. So in some ways, doesn't this sound like containers and Kubernetes? We're no longer in a position where we want to make changes of any sort, even security related, against an active running system. Why not make that change to the code and then flip the system to running the new code with the ability to flip it right back, right? Sounds just like what we do with containers and Kubernetes and with blue-green deployments. And it's also, this is the source for the immutable operating system that we call Red Hat Core OS, which serves as the infrastructure for OpenShift deployments. We're in IT for a long time, we've used this phrase, eating our own dog food. Somebody suggested to me we should say it's like drinking our own champagne instead. But the idea is the same. We have fully adopted this idea for how to manage the underlying infrastructure for OpenShift, to not only make it more secure, but to make it easier for our customers to perform upgrades. And if anything goes wrong with the upgrades, to revert immediately back to a working state. So back to our options. So we talked about RHEL for Edge and how that might fit in how you architect and deploy new systems. So let's talk about the options with Red Hat OpenShift, our containers and Kubernetes platform. So you have 3 rows there: single node edge servers, space constrained environments, and 3 node clusters. So in the top, imagine that. Actually, let's start on the right-hand side. In your central data center, you probably have some sort of OpenShift environment running there. And the question is, how do you extend that intelligence, that power of running containers in an orchestrated way for all sorts of workloads to the edge? So in the first case, what you're doing is you're extending that Kubernetes cluster to a smaller cluster of a single control node and a worker node. That's what the C and W correspond to. And that's possible. And it's a good option for low bandwidth or disconnected sites, because option 2 below that is a good option too, where you can put less hardware in the field, but it means you have your control nodes in something like a regional data center. Well, what that requires is that you have better communication from those control nodes to the worker node. So again, sometimes you need, your available bandwidth or latency or network reliability will play a part in which of these solutions that you choose. And then finally, we are also offering a 3-node OpenShift cluster, and that combines the control and the worker nodes in a way that you could lose a full node of those 3. So 1 out of the 3 nodes can go down completely, or on purpose as part of an upgrade process, and your application continues running in the containers that run on top of that platform. So thinking through these, again, there may be good reasons. Let's think through this. So RHEL for Edge versus these OpenShift-based deployments. It's going to depend on the workload that you really need. So I think in the typical workloads we think of today, maybe most, if not all of them, can run efficiently on RHEL for Edge. As you end up containerizing more of your applications, maybe running those applications on OpenShift starts to look a little more compelling. You could still run containers on RHEL for Edge, but as you want more and more sophistication on how we're running containers, maybe eventually you're looking at running single node edge servers or something like that running OpenShift. Another thought, again, as these workloads evolve, there's been a lot of talk. I think the big CIO buzzword these days is AI ops. So the idea of using artificial intelligence to make smart decisions and then act on those decisions, even as far as the remote nodes. So we hear more about wanting to do security automation, for example, using AI ops. So again, using processing data, using artificial intelligence to determine, is this normal behavior or is this an attacker? And then automating a response to that attack. That's what we're trying to do. So as we get further down that road, now I still think there are a lot of good things you can do for security before you have to invest in AI ops and things like that. But knowing it's coming, and we do have some advanced customers that are thinking about this kind of thing now, they are already today thinking about how I can deploy AI systems, in these remote edge locations. And the ideal way to do that would be something like OpenShift to do that. But of course, the trade-off, and there's always a trade-off, OpenShift requires much more horsepower in terms of the hardware you run at those remote locations. So again, it's all about the workload. It's all about how your application is designed to run, what it's supposed to do. It's going to depend on the bandwidth and availability of the network that you have connecting them, and so on. But your account team, our domain architects, myself, we're all more than willing to work with you to talk you through these options and the best options for your particular applications and systems. Now, cloud and hybrid cloud play a part here as well, as if you can imagine. Sometimes the easiest way to roll out this capability is using the fact that these clouds are already ubiquitous and spread across the country into different cloud data centers. That can be used in a combination with your existing data centers today. So maybe your hub remains in Salt Lake City and Atlanta, but you can add extra edge capability by building into the AWS or the Azure cloud. That could be a quick way of sort of extending some of these edge capabilities out. And then your truly remote devices could connect to the cloud first, and from there into your Salt Lake City and Atlanta locations, just as an example. Um, and then we have, and it's worth pointing out here, the point of this diagram is really that we do a lot of work as a hybrid cloud company to ensure that our technology works on any of these environments, whether it's physical, virtual, private cloud, public cloud. OpenShift in particular ensures that your application is going to run the same way everywhere, whether it's in your data center or in the Azure or the AWS or even the Google Cloud, and whoever comes next. So it's important to point out that this is already happening. This is not, I would not call this bleeding edge at this point. We have plenty of customers in manufacturing and engineering, and in particular in telecommunications, that are following this exact model. They know they want to deploy more compute power at the edge. That's exactly what edge computing means. And in telecoms, we've already talked about them using virtual radio access networks as part of the 5G rollout. In manufacturing, I think I had a previous slide that, they have walking dog-like robots that roam the manufacturing facility and map it all out. And arguably that's another form of edge computing. And then, of course, the autonomous monitoring and autonomous vehicles that the energy industry is rolling out are all following this exact same model. So I don't think you need to think about, I think one of the lessons here is that you don't necessarily have to be a cutting edge.com to be thinking about rolling these things out. If manufacturing is doing it and telecoms and industries, sometimes they've been very staid in how they've rolled out new technologies. So you don't have to wait for a brand new program or a brand new project to do this. There could be FAA applications out there today that could benefit, the next time there's a hardware or a software refresh, from adopting RHEL for Edge, for example, as a better way of deploying that software today. So just to summarize, we talked about two different solutions and then the glue that holds them all together. So RHEL for Edge, it's still the same Red Hat Enterprise Linux that you depend on for performance and security and stability today. It's not a different version of this. It's simply a different way of managing those packages, that operating system file system on your systems in a way that makes it easier for you to manage in the field, in an inaccessible location, in situations where you need to have a much faster or more reliable failback, in areas where you might have intermittent or poor data communications. And again, we can do great demos of this anytime you want. And then there's the idea of using, extending OpenShift deployments, extending your current use of containers and Kubernetes within FAA out into the field, whether it be into portions of the cloud or clouds, or into smaller hardware footprints that used to be available in those remote locations. And finally, you're going to find that you don't want to do any of this without automating all of it from the beginning and automating changes that you need to make to those systems. Automating those software deployments, automating when you do those reboots, that you first ensure that they have the latest version. You ensure that they do the reboot when you want them to do the reboot. And then you're able to check those systems before they go live, or even force a rollback of whatever change you made. Those are all the kinds of things that you can automate and orchestrate with Ansible. So I'll stop there and ask if we have any questions.
Nope. Sebastian, no questions yet.
Okay. So that's really the end of what I wanted to present today. We can wait another minute here to see if there are any other questions, follow up.
Yeah, I think we're good. So
Okay.
with that, yeah, Sebastian. So with that, thank you, for talking to us about the edge. And with the questions, I dropped my email in the chat. Feel free to reach out to me if you have any questions. I can get you in touch with Sebastian if you want a deeper dive in this, a demo per se. Always feel free to reach out to me as well. We might be doing a deeper dive later on in a later webinar as well if the interest is there. But yeah, always feel free to reach out to me, and we can definitely schedule something about that. Yep, Sebastian, thank you. As always, Jeff Thompson, thank you for helping us out today. He does a lot behind the scenes, as well as Catherine Brady from the Red Hat account team. She's been doing a lot of the legwork behind the scenes as well. CDW, DLT, our partners, for taking the time to help us set this event up, sending out invites, setting up the website for us to host this stuff. And that being said, we do record this webinar. It will be posted in the DLT portal under past webinars. So if you missed something, you want to show your friends, hey, listen, look what Sebastian told us about. You can send them the YouTube link from there as well. I also, during the presentation, dropped a link in for Red Hat Summit. This year it is all virtual again. It is April 27th and 28th. And the best part is it's free. So I urge everyone, sign up using that link. If you can't make those days or certain talks, they're all recorded. You can go back and watch them on demand. You also get plenty of information from the summit. You can go back to or watch demos of. I'm still watching demos from 2019. That there's a lot of great material that comes along with that. So again, it's free. Just sign up, and yeah, just watch the stuff. And with Red Hat Summit at the end of the month. I did want to say we are going to skip our normally scheduled program in 2 weeks. We don't want to overwhelm the FAA with tons of webinars and other talks. So we're going to pick up our webinar series sometime in May. So we'll give you guys a little bit of break. And with that, as long as Jeff doesn't have anything, I did hear somebody talking. Myself and the rest of the Red Hat account team, we thank you for taking the time to come and listen and talk about the edge. And I'll see everyone next month. Again, Sebastian, thank you so much. Really appreciate it.
Thank you. Thank you. Talk to you soon.